Okay, and welcome back to what I believe is the final video for this week. Okay, so again, a little bit more security stuff. So, no, don't worry. This is not going to suddenly appear on the final exam. I kind of don't plan on making this show up on this week's lab exercise either. But I mean, just be prepared just in case. But I'm pretty sure not on the final exam. Okay, so I haven't made up this week's lab yet, but I'm kind of not thinking at the moment. All right. So here we go. I've been busy again with my fake data. I've added an extra field. Okay, so here we go. So now, of course, we've got our passwords. Our passwords are no longer plain text. They've probably been SHA-256 encoded. Yeah, I still have the old numbers in here. Okay, that's fine. But now take a look at this. Woo, hey, look at this. Now we've got credit card information. And of course, if we have credit card information, this would also be just as bad. In fact, that's probably even worse than having the passwords in plain text. Okay, so let's see if we can solve this problem. Now, credit card information is a little bit different than passwords. Okay, although it's perfectly fine. I mean, here we go. Here's somebody's credit card number 123443221 12344 4321. This is obviously not a valid number, or if it is, I pity the person who has that card. You could obviously take this and you could apply one of these hashing tools to it, and you'd end up getting a hash, and that's fine. And you could store that. But the problem is why did you store the credit card information in the first place? Okay, the reason why you would probably store credit card information if you wanted to hang on to things is so that later you could apply a charge to the card every month so that you could extend somebody's parking fees. Okay, or at least you'd have to hang on to it long enough to get the number processed from the bank, and then you would get rid of it. Okay, so you probably wanted to have it at least for a little bit of a while. But if you wanted recurring charges, maybe you'd hang on to it. Okay, so the problem is that these hashing functions don't work because although you can take a number and turn it into something that you can't read, you can't take that and turn it back. Okay, so let's see if we can find out how to solve this problem. In order to be able to store numbers like this in a way that nobody can read them and bring them back, you don't use hashing, you use a mechanism called encryption. Okay, and luckily for us, that library that I showed you a little while ago called SJCL happens to have a bunch of stuff built in. SCJCL has a bunch of stuff built into it, and one of it's called Cipher. Okay, and there's a bunch of very popular ciphers. By far the most popular cipher is something called AES, which is Advanced Encryption Standard. So it's a well-known standard out there, and yeah, this stuff is already built in. So guess what? We're definitely going to be using this. Okay, let's go back, and I'm going to give you one quick little demo about how this could be used to encrypt some data, and then I'm going to leave it to you as an exercise, if you wish to go off and actually try it, to actually try encrypting the data. So this one is a little bit more work than the password hashing, but it certainly is possible. All right, I'm going to do my work back here in the map demo. Okay, so first of all, let me have the credit card number, CC number. Okay, so this is a plain text everyday number. Now, unfortunately, this library is a little bit of a pain to get going. It's not terribly difficult. It's only a couple of lines, but to be able to make use of it is a little bit more work. Okay, here's what we're going to do. So here's my original number. The second thing that I need to do is I need to have something called an encryption key. Okay, the encryption key has to be something that only I know and it never gets out. Okay, so now this could be anything at all. It could be, well, it could be this, I suppose, but maybe that's not a good one. Instead, what we're going to do is we're going to use something that's very completely random looking. Okay, well, you know what? This is a website that I use quite often. Random password generator. Okay, this provides me some really nice looking passwords. Okay, and of course, I mean, the reason why you use difficult to figure out passwords is because you don't want somebody else guessing what the password is. Okay, going. Hello. Okay, that seems to be not answering me today. All right, 5 generate passwords, 8 characters long. Okay, all right, fine, we'll use this one. Yeah, well, those will certainly be big enough. Okay, so that's usually not the one that I'm using, but let's use this as a password. Okay, because I'm guessing nobody will end up guessing that one. And here's what I want to do. Okay, in order to use the encryption mechanism, it's a little bit involved. Okay, so first of all, when you take something and you encrypt it, the result is something called ciphertext. Okay, so but what I'll call it encrypted data. And here's what I'm going to do. So it's a little bit long. It's SJCL encrypt, so it's not helping me at all. And what we need to do is let's encrypt the credit card number using the key. CC data, gotta get the right one, sorry, wrong parameter. The first parameter up is the actual encryption key. Okay, so the encryption key, the number I'm really trying to encrypt is called the credit card number, and I'm going to include this extra thing. Now, I'm not even sure if I need this. I should have tried this without. What it is, it's some parameters that go in. Okay, and there's a couple of these parameters I need to go in, and we'll try this in a second to see how this works. Okay, and what I'm going to do is let me do console.log encrypted data. Okay, so let's go and take a look at what this looks like. So load up the page. Okay, so here we go. Ignore this thing right here. Okay, what do I see? I see a big long string, and by the way, it is a string. Even though it looks like a JSON object, yeah, it's a JSON string. You can see that it used 1,000 iterations using a key size of probably 128 bits, and it's actually this thing right here is the important stuff. That's the actual encrypted data, just the last little bit. Everything else is actually not part of it, but if you include all of this stuff, it ends up making the decryption quite a bit easier. Okay, so really it's just this one thing here called ciphertext. Now give me 1 second because I didn't have a chance to try this. I was curious to know whether or not it works without these other two parameters, because that will probably make your life a little bit easier. Okay, good. So that is actually working. Okay, so in that case there's no reason to add anything else. In fact, you'll notice every time that I load this page, it produces a different salt. Okay, and what this is done to make it harder for people to crack your passwords, because the actual ciphertext keeps changing because of this thing called salt, and salt is basically some random stuff to make everything a little bit more difficult. Now, if you wanted to decode this value, you see what you can do is you can take this entire string. Okay, in fact, you know what I'm going to do? Let me take this entire string, and I'm going to come back over to here, and I'm going to comment out this entire block of code, and I'm going to say let encrypted data be equal to that full string. Okay, so that's the actual string. All right, now if I actually wanted to decrypt this data, here's what I need to do. Okay, so let's call it decoded. What I do is I go to SJCL and I ask to decrypt, and I give something, which I'll explain in 1 second, followed by the encrypted data. Okay, so what's the something that goes here? Well, that's actually the encryption key. So if I take this string right here and paste it in place, oops, not like that. If I paste it in right here, and I console log the decoded value, let's go take a look and see what happens. Okay, you can see what I get back is I get back the original string. Okay, so it gives me back the original credit card number. So you see, this is the actual encrypted data. So if somebody broke in and they saw just this, it's perfectly fine. Now, what about it? What about all this other stuff? Well, as I say, just makes my life a little bit easier. Okay, it doesn't have to be actually stored, but if we store this entire thing, that would be perfect. Okay, so in other words, rather than going and storing 1, 2, 3, 4, 4, 4, 3, 2, 1, 1, 2, 3, 4, 4, 3, 2, 1 inside this thing right here, what I would instead do is I would take that big long string that I just had, so from here up to the end, and I would store this. Okay, so instead of storing this, I would store this as the actual credit card information. Okay, because guess what? Nobody can see this. Now, can anybody decode it? Well, the answer is yes, they can, but only if they happen to know this magic letter. For example, even if I change this by one letter only, just from a C to a D, I come over here and I reload the page, you'll see that, hey, look, it's being corrupted. It actually cannot be decoded. Okay, So let's go back and we'll put that back as it was a second ago, and we'll put it back to a C. And of course, if you have exactly the right thing, it decodes, but any little tiny thing that changes and the entire business is out. Okay, so of course, what do you do with this password? Well, you got to keep the password absolutely secure. Okay, you can't let anybody else see this, but unfortunately, the way how it's set up here, it's actually coded directly into the source code, so that's not so secret. But normally, what you'd end up doing is you'd probably leave that onto a server or typed in just at the last second and never actually stored on the disk. But that's way beyond the scope here of this course. So all that I want you to do is to see what encryption looks like and how it's different than, say, hashing. So hashing is for one direction, and encryption is for other things. So what I'm going to do is I'm going to leave this with you as something to do. So after this video, but I am going to call this one optional. I'm afraid to do that because once I put the word optional, I know nobody tries it. So, but anyway, I'll give it a shot anyway. Okay, so optional. Encrypt the credit card numbers, okay, using the SJCL library and AES encryption. Okay, use a long password. Okay, what do I mean by long password? Okay, do you remember when I did the first part? Here, let's go over here for one final time. Okay, let me comment out this one, and I'll comment out the decryption because we don't need it anymore. Okay, so we'll only encode the encryption. Take a look at this. If I add a whole lot of extra letters to my encryption key and I reload, okay, that's about the same. Let's include some extra things as well. Okay. All right, so no, that ended up not making any change. That's fine. But obviously, this would be a much harder password to end up decoding. So sorry, put that away. Let me go back and pretend I didn't say that. Okay, so here's what I want you to do is to go and encrypt, but use a long password. So not one or two letters, but actually use quite a bit. And on the customer details screen, show info about the customer. About the customer who just logged in. Okay, so what do I mean by this? Let's go back over to here. Here's my customer details. Please put in a name, and you could use a span for this, BR, and you could put in the CID, again, span, question mark. And, well, let's have the CC on file, and this could be a span. And of course you want to fill that in. You want to give the spans an ID so that once you log in, you can actually pull up the data and make it appear. So of course, when you pull up the information about the credit card, well, you actually want to see the actual credit card that was stored. In other words, decrypt it. Okay. So show the card just logged info about the credit card who just logged in, including the decrypted credit card number. Okay, so go off and give this one a try. That is the end of the exercise for this week. So as promised, my intention was not to make you worry about doing things like password hashing and decryption for the upcoming lab and for the final exam, but I am getting you to do lots of extra exercises so that you get more practice, and it more has to do with the extension. That's actually more the important stuff. So local management, oh, look at that, I didn't even do it, extends customer management system. So it should mean like this. So sorry, I didn't get that one put in place. So that's what these whole things, that's what all of this stuff is about for this week. Okay, the other stuff is just kind of some bonus things, because like anything else, the more time that you put into actually practicing, the better you'll end up getting. Okay, all right, so I'll leave here with this one. Okay, so be prepared, by the way. Have this customer management system put in place for the lab exercise coming up. So guess what? My sort of expectation for the lab is about this stuff here, but don't worry, it's not going to be about it's not going to be about AJAX loading, asynchronous loading stuff. It's not going to be about encryption, but obviously I've got lots of other things that I can put into place. Okay, so see you later.